In the previous lesson, we learned what a computer is and how it processes information. But here's something interesting. A computer can perform billions of calculations every second. It can run games, browse the internet, edit videos, and even help train artificial intelligence. But have you ever wondered, how does the computer know what to do? The answer is surprisingly simple. A computer doesn't think. It doesn't guess. It doesn't make decisions on its own. It only follows instructions. A sequence of instructions that tells a computer exactly what to do is called a program. That brings us to another important question. What is programming? Programming is the process of designing and writing those instructions so that a computer can perform a specific task. The person who designs and writes these programs is called a programmer. Without programs, a computer is simply an electronic machine with no idea what tasks to perform. Every application you use, every game you play, every website you visit, exists because someone wrote a program. But how are these programs written? They're written using programming languages. What is a programming language? A programming language is a special language used to communicate with a computer. Just as people use languages like English or Amharic to communicate with one another, programmers use programming languages to communicate with computers. Every programming language has its own rules and syntax. These rules allow programmers to write instructions that can eventually be understood and executed by the computer. Today, there are hundreds of programming languages. Some of the most popular include C++, Java, Python, and C#. Although their syntax is different, they all have the same goal: to tell the computer exactly what to do. Types of programming languages. Programming languages are generally classified into three categories. Machine language. Machine language is the only language computer understands directly. It is written entirely using binary digits, 0 and 1. For humans, this language is extremely difficult to read and write. It is also machine-dependent, meaning a program written for one type of computer may not work on another. Because of these limitations, programmers almost never write programs directly in machine language. Assembly language. To make programming easier, assembly language was introduced. Instead of binary numbers, assembly language uses short English-like words called mnemonics. For example, load, add, store. These instructions are much easier for humans to understand. However, assembly language is still machine-dependent. Before the computer can execute it, it must first be translated into machine language using a program called an assembler. High-level languages. Most modern software is written using high-level programming languages. These languages are much closer to everyday English and mathematical notation. For example, instead of writing hundreds of binary digits, we can simply write sum equals number 1 plus number 2. Much easier, isn't it? High-level languages are also portable, meaning the same program can run on different computers after it is compiled for that platform. Throughout this course, we'll be using C++. How do programmers solve problems? Many beginners think programmers immediately start writing code. In reality, that's usually the last step. Professional programmers first understand the problem. Then they plan the solution. Only after planning do they begin writing code. A typical programming task has two phases. The first is the problem-solving phase. The second is the implementation phase. During the problem-solving phase, programmers understand the problem and design a solution. During the implementation phase, they translate that solution into a programming language such as C++. To design a solution, programmers usually use three important tools: pseudocode, algorithms, flowcharts. Let's look at each one. What is pseudocode? Pseudocode is an informal way of describing the solution to a problem using simple English. It isn't a programming language. It doesn't have strict syntax. Its purpose is simply to organize our thoughts before writing code. Let's solve a simple problem. Find the average of two numbers. The pseudocode might look like this. Start. Input the first number. Input the second number. Calculate the average. Display the average. Stop. Notice something important. Anyone can understand these steps, even someone who has never written a program before. That's exactly why programmers use pseudocode. What is an algorithm? Once the idea is clear, the pseudocode is refined into a more detailed algorithm. An algorithm is a finite sequence of well-defined, ordered steps used to solve a problem. For our example, the algorithm becomes: Step 1, start. Step 2, input number 1. Step 3, input number 2. Step 4, average equals number 1 plus number 2 divided by 2. Step 5, display the average. Step 6, stop. Unlike pseudocode, an algorithm focuses on precision. Every step must be logical, complete, and performed in the correct order. What is a flowchart? Sometimes a picture is easier to understand than a page of text. A flowchart is a graphical representation of an algorithm. Instead of writing the steps as sentences, we represent them using standard symbols connected by arrows. The most common symbols are an oval for start and stop, a parallelogram for input and output, a rectangle for processing, a diamond for decisions, and arrows that show the direction of execution. Flowcharts help programmers visualize the solution before writing code. They also make it much easier to explain a program to other people. For our example, the flowchart would look like this: Start. Input number 1. Input number 2. Calculate the average. Display the average. Stop. Notice how each symbol represents a different type of operation. From problem to program. Now let's put everything together. We started with a problem. Next, we wrote the pseudocode. Then we refined it into an algorithm. After that, we drew the flowchart. Only now are we ready to write the program. Using C++, our solution becomes: Don't worry if this code looks unfamiliar. We'll explain every single line in the next lesson. For now, remember just two important statements. Sin is used to receive input from the user. COUT is used to display output on the screen. The important lesson here isn't the code itself, it's the process. Professional programmers don't start by writing code. They start by understanding the problem. Then they plan, and only then do they write the program. Once you learn this way of thinking, programming becomes much easier. In the next lesson, we'll write our very first C++ program and understand every line of code step by step. Thanks for watching, and I'll see you in the next lesson.